morning, good day, good afternoon, good evening, good night, wherever you are in the world. Welcome to the stream. All right, today's an open stream. Just to pick up from yesterday, I was supposed to be streaming yesterday, but my student canceled, and um, I wasn't given anything to prepare at that time, and then two, I had a few errands to run yesterday, so I decided to finish the errands first. But with that, here we are on the street. Hello. Hey, nobody's here yet. Like I said earlier, this is an open stream. Anyone can come in, ask questions about physics or math, and just ask. Okay. Now, this is an English only stream, just so we're clear, because I've had a few uh, guests who were asking if I could speak their language. So unfortunately, just to keep it fair for everyone, this is an English stream. Okay. English language stream. No one's here yet. What to do? Because I'm actually thinking maybe, just maybe, we'll take a look at some equations in physics, which I think a lot of students would be familiar with, but don't still quite get on what the exact reasoning behind it is. So, all right. Of course, we'll go only through classical physics, not including relativity, and maybe some of the more um, simple concepts in quantum mechanics. But again, still don't know at this point. Wonder if anyone's joined the streams yet. So let's check out the different places. Um, hmm. Yeah, I don't really talk to myself a lot just like this. But of course, when it comes to thinking and coming up with stuff, yeah, I got something. Okay, no one's here yet. We'll stream for probably an hour today. Okay. Hmm. I have an idea while we're waiting. How about we go on to YouTube? Yeah, I think that's a good idea. Let's go to YouTube and then let's react to those videos. What do you think? If anyone's there on the stream, what do you think? I think it's a good idea. Hmm. Still have nothing. All right, so in that case, yeah, we'll do that. We'll change modes real quick. Yep. Hmm. Okay, I have a couple of ideas. One is we're just gonna go through different equations in physics and say, well, let's kind of discuss the history behind those equations. Okay. Specifically, hmm, okay. All right. Well, the stream was supposedly it was supposedly for, again, it's for my students who are gonna take the IBDP physics exam soon, and that also means their mock tests are coming up soon. So if their mock tests for my students are gonna happen next week, and let's see what happens. This is the syringe I used for the last short that was about clouds. And hopefully you can see it. The alcohol and water mixture is still in there. Let's see if the cloud still works. I'm gonna try this. Hopefully you can see this clearly. Okay, so it's the same thing. See, unedited right now. There's a mist forming on the inside, but not much. Now, if I, it's a bit difficult. If I release, right, you couldn't really see it on the stream, but I think you can see inside. It's clearing up now, but at the beginning it was like, yeah, it still works. Let's try one more time and then, okay, one more time. So right now a bit clear. Let's see if it clouds up. Yep, it clouds up from what I see here, but I don't think you can see it on camera. But anyway, hmm. All right. So I guess we'll go there. Okay. So if there are any IBDP physics students out there, I'm open for suggestions. If not, I'm gonna go through a list of commonly asked questions. But for us to do that, I'm gonna actually go on Google and search for what I just said. Let's put that up. Oh, okay. Here is okay. I just found a good resource here. I'm looking at Tumblr, and let me see this. Okay, nope, doesn't quite matter. Um, no questions here. Let's look for another one. Okay. All right. So while I'm just gonna talk here. So how do you actually take an exam for IB physics or for any physics exam for that matter? Okay. So we know that no matter what kind of exam it is, there's always going to be a multiple choice question. Okay, let's go to the board. So taking an exam. Okay, so again, this is a reminder for my students and for those who are not familiar with things, I will also write them down. Okay, so tips for the exam before we do anything else. Ah, exam tips. This is not only for IBDP. This is for any kind of exam. Okay, okay. The first one is that for MCQ. We're gonna go to the by paper first. By paper, so multiple choice papers. Multiple choice. Okay. The one thing that you need to remember for multiple choice is that there is always an answer. Okay, so that's the first one. The second thing that we need to remember here is that there's this is a bit about this is not about physics. This is about studying and learning. Okay, there are two types of memory. I was just reading about this yesterday because I remember reading about it before, and I'm studying for something myself, and the thing I'm studying for is a test, and it's like the SATs. It's an all multiple choice question paper. Okay, so I was thinking that maybe there's a way for me to hack this with the two types of memory. Okay, speaking of which, let's continue. There are two types of memory. Okay, okay. The first one is recall. Recall. I'm gonna change this. There are two types to retrieve information from information from memory. Okay, the first one is by recalling. This is the one. This is the one that we normally referred to as remembering. Okay. Okay. What do I mean by this? A lot of when you say, "Do you remember something? Do you remember when blah 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 blah?" Or that's one way to say it, but sometimes the other way is, "What do you remember about something?" Okay. So basically, recall here is I'm gonna use a word that's used a lot whenever this topic is discussed. The idea is you're retrieving information from activity. Okay. Now the other kind of memory, this is gonna be important later on. Okay. Now, and this is the recognizing. Okay. The other one is to recognize something. This is I see, I see it, I remember it. I, it gives it calls memories back. Okay. Now, why am I referring to this? Because here's the thing: recalling something, retrieving it from your memory, from your brain. This is actually the deeper learning or deeper information. Okay, I'm just gonna say learning because it's the idea here. Recognize is more. I'm not gonna say it's very shallow. It's just less deep. It's less deep. Okay. However, another key difference between these two is that recognition is faster. This recalling something is slower. Okay. Now, the reason why I'm putting this up here is because whenever you're trying to study for a test, you want to be able to recall it. Because if you can recall it, you're more likely to recognize it, right? So, there are two ways to study for tests. Recalling is active, is studying the material. Okay. Now, recognizing the way we hack recognizing this is where past papers and exam conditions are done. Why? Because once you're in the first part is obvious when you have a lot of past papers. You practice a lot of past papers. Um, when you practice a lot of past papers, you're basically putting all the answers in your head. You're not actively trying to memorize them, but it's still there. It's still going into your head. So when you see it later on, when you see something very similar, you know what the answer is. Okay. Now, the exam conditions part, this helps you with the recognition because part of recognition, part of memory formation is the context. So, for example, um, if you're, I'm gonna give this well, not in a classroom. I'm gonna give this another example here. Let's say that when uh, you were drinking a coffee, you're drinking. Let's say you go to some coffee shop like Starbucks, right? So you're drinking your coffee, and then you saw somebody bump into the door, into the glass door. They were walking and they go straight into, they slam into the glass door, right? Uh, you're more likely to remember, you're more likely to recognize that glass door. And when, sorry, not recognize, you're more likely to see that glass door and remember the person bumping into it rather than actually remembering the person, it's the person who bumped into the thing. You're because the environment matters. Now, in another context, let's say we have the same idea. You see a glass door. Whenever you see a glass door, you remember that person, right? So that's like recognition. So that's putting yourself in a condition, in a context, and then you remember the person, right? So these two should help. So uh, for those in my classes, this is why for the past month, I think, for the past month, this is all we've been doing: past paper questions, right? It's for you to do both studying for material and that's for recall, and then for recognition, it's okay. Now, why do we do this? Because in certain ideas, or the easier ideas are always easier to answer, and you would rather just recognize the correct answer than for those simpler answers, right? Then you, and then when you try to recall, that's when you try to remember. Okay, this is how to solve it, blah, 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 right? So that's for multiple choice. For structured questions, basically structured questions would be anything like, well, it's not. Oh, hey, Sebastian is here. Thank you, Sebastian. I see. Thank you for the compliment on the code. Well, this is actually a lab code. Okay. Anyway, so what was I saying? So, Sebastian, have you been listening into the stream that whole time when I was discussing this? Hopefully not, or hopefully rather, so I wouldn't repeat myself. Well, if you want to go back, just go back to this later. Anyway, so that's first test taking technique. Okay, the second test taking technique is for structured questions, structured papers. So these would include your calculations. Okay, this would include your true or false. Well, true or false is still actually under multiple choice. So, okay, so these would be your essay type questions. Okay, what else would you put in here? For those who are actually in Cambridge or no, SATs are mostly multiple choice. Of course, IB, Cambridge-based systems, the ones using the UK systems like Singapore-based curriculum or the UK-based curriculum. Structured, we have excuse me, we have we just have word problems. Okay, and these word problems are not just by solving; they include like explaining. So it includes explain, stating, solving. What else? What is different, or the odd one out? That's actually multiple choice. Never mind. Okay. Well, okay, but these kinds of questions, where you don't have something to choose from. Okay. So what's gonna be the tip here? It's it's exactly the same as this. You still have to retrieve information from memory, and therefore, you still have to study by studying the material. But you also have to make sure that when you study, you use past papers and past resources and do it under exam conditions. So the exact same thing. Okay. So that's the first one. I'll just type this in. So same ideas as in execute. Okay, so that's the first one. Another thing that would be useful for structured questions, okay, is to understand the instructions. Hi, director. WSP. What's WSP? All right. I'm just gonna do this thing. Okay, there. So, um, so of course, to understand the instructions, the easiest way to go back there is to go back to this idea of recognizing the keywords. Okay, all right. Okay, so anyway, so in short, what do we have to do when you study? So to study well, this means two things. Okay, remember the material as much as you can. remember the key ideas, and then um, practice, practice, practice. Okay, so now I'm pretty sure your other teachers say the same thing, but I'm explaining here why it works. Okay, especially for uh, especially for younger learners like you guys who are on the stream right now. Okay, so again, remember the key ideas and practice, practice, practice. Now, in the classroom, we can discuss further later on how that works. But for now, we'll stop here. Okay. All right. So, guys, those who are on the stream, like I said, this is an open stream to me. That means if you have any questions, you're free to ask. As long as it's about math or science, general science, or more or like higher level physics, go ahead. Okay. That is if you have any questions. Hmm. Okay, I'm looking at the live viewers in YouTube. We have four. And oops, let me open uh Facebook real quick. Twitch, there's one live viewer. I think that's me. Uh, all right. No, okay, no one's watching on Facebook yet. All right, but anyway, questions, questions, questions. Ah, okay. Redstone Baron plays. Do I know you personally? Either way, I'll answer that question. That's a good question. So, what does the mitochondria? Can you elaborate to that question? I think I know what you mean, but can you give me some more details so I can explain this further? Mitochondria, particle zoo. Okay, we'll go to particle zoo and quarks later. Who's blah blah blah? Yeah, again, identify yourself if you can, if you'd like to. All right, I have two questions so far. I think I'll answer the mitochondria question real quick. Okay. All right. So, I'll just put that question from the stream onto the board first. Okay. Hold on. Okay. So the question here is what does the mitochondria rely on? Ah, what? Okay, that's a better question. What does the mitochondria need to function properly? Okay. So that's the first question. I'll try to answer that in a simple way first, and if you need a more detailed answer, you can ask later. Okay. So the simple version of this first. Okay. So we all know, well, not all of us, but for those who have studied parts of the cell, the mitochondria. This is plural, by the way. Singular is mitochondrion. Okay. Mitochondrion. That's the singular. Okay. Um. Okay. This you probably hear this over and over again in class, YouTube, textbooks, whatever. I'm just gonna repeat what these sources always say. These are the powerhouses of the cell, right? So, before we can answer this question, we wanna know what its function is. Okay, Now, the more specific way of doing this is it converts, or the one mitochondrion converts um, ATP, this molecule, okay, into ADP, so into some other molecule. Okay, now in this process, okay, or better yet, I'm just gonna simplify that for you. So it converts ATP into simpler products. Just gonna say it like that, into simpler products, and releases energy. Okay, energy. So this already basically explains what the mitochondria needs. It needs ATP. Oops. Let's undo that. Hold on. So mitochondria needs ATP to function. That's the first one. Okay. And of course, nothing about cells function without a source of energy. So it needs a source of energy as well. Okay. Source of energy is needed. Okay. And where does that energy come from? It usually comes from the breakdown of the food you eat. So it comes from the breakdown of carbohydrates, the breakdown of the fats if you're low on carbohydrates, and then the breakdown of proteins if you're low on both. But basically, the energy, so the food is converted, is digested first into glucose. Okay, and this glucose goes into powering the mitochondria. So these are the two things. Okay, and the last thing, this conversion of ATP, there are two possible ways to do it. Okay, this conversion of ATP needs two things. Well, doesn't really need to. It can happen two ways. First one is anaerobic, anaerobically, anaerobic, and we have aerobic. Okay, now anaerobic means no air. So when you say air here, you think oxygen. Okay, so aerobic here is going to be it means air. So okay, so these so for humans, yeah, for humans and a lot of my multicellular organisms, we do aerobic respiration, multicellular, right? So this is the third thing we need for mitochondria to work, at least for multicellular organisms. But what's essential? Just the presence of the ATP and the source of energy. Okay, this is needed for multicellular forms. Okay, so that's a simpler explanation. Not simpler, but I wouldn't say complicated as well. Maybe the middle explanation. Okay. All right. So that's the idea there. Hope I hope that's clear. If you want to clarify that further, you can let me know in the chat. Okay. Blah blah. Particle zoo and quarks. We've actually discussed that last stream, right? But okay. Again, I'll do this quickly. Particle zoo and quarks. The idea here again is let's just put this here. Particle zoo. Okay, so for particles in quarks, again, this is best explained through the history. Okay, so again, particles in quarks, let's just say history. This is a timeline. Okay, and let's say your time is going. Let's keep it standard. Make it go up. Okay, this time around, I'm gonna actually look for the times because the idea is it makes sometimes the discoveries make sense in the context, right? So, uh, when were quarks proposed? Okay, according to the timeline here, this is 1964. Quarks were proposed. Okay, so the idea is before 1964, before 1964, um, something needed to be explained by quarks, right? So what was happening here? That's the question, right? Here, the idea here, I'll put this in the text box. Okay. Okay. Hold on, I'll make this longer instead. Okay. Okay. So here's the idea. Okay, let me just. Where's my mouse? Ah, there it is. Okay. It's a bit too small. I'll make this a bit bigger. Okay, I think that's good enough. So okay. So the idea here is before we go to 1964, before we go to 1964, we go to another year, an earlier year. When I'll just put this here. When okay, the neutron was discovered in 1932. I'm gonna put that here. The 1932 neutron was discovered. Okay. Uh, okay. What's the importance of this? Because here, scientists had the brilliant idea of colliding or smashing protons, neutrons with protons, and neutrons with neutrons. Okay, so after the discovery of neutrons, in fact, what they did was not just like that. Okay, neutrons. Um, Scientists started smashing. Okay, of course, it's really difficult to smash a proton into a proton or a neutron into a neutron, but they did the next easiest thing. They started smashing neutrons, and I'll say and eventually protons, yeah, into large nuclei. For example, they did it to cobalt, iron, etc. Okay, so that was what's happening in these years. Of course, we kept doing that, but but basically this is our focus. It's just this time period first, okay? And what happened was there were so many this particles discovered, okay? So in this, particles were discovered, okay? What particles did they discover? They started discovering the pi particles, pi, yeah, literally like the Greek letter pi. But later on, they discovered there's like three types. There's pi plus, there's pi minus. Oh, sorry, there's two types, pi plus and pi minus. Okay. If you call it in a word, you call them pions. Okay. Now later on, we get k particles, so we call them kaons. Yeah. Okay. And kaons come in three distinct flavors. We have k plus, k minus, and k neutral or k zero. And then they discovered more. Uh, and others, right? And hundreds of others. Okay, so this hundreds of others, this is now the what we called the particle zoo. It's a collection of all these new subatomic particles. Now, again, the key idea here, at least for IB physics, aside from you knowing how to do this, is also the key idea of, wait a minute, this is supposed to be simple. Why are we getting 100 plus particles? This is not supposed to happen. We're supposed to keep it simple, right? All right. So the question is, so basically the scientists basically said here, what doesn't make sense? Okay. So what happened was, in these 32 years between 1932 and 1964, there were a lot of different ideas being proposed to explain the particle zoo, and then these two scientists, and who are the scientists here? These were what's his name again? Murray Gell-Mann. So these were physicists, okay. And the other one, these were independent. They didn't work together. They happened to put onto this independently. Okay. And the other one was, I forgot his first name. It's White. Okay. I'm gonna check his first name just to be sure. George. So I'll just say George White. Okay. Again, these two people, they were independent. They didn't collaborate. They came up with the same idea, and so they both won the Nobel Prize for quarks. Okay, so that, I hope that clarifies why we had the particle zoo. Okay, Redstone Baron, clear? At least for this part. Hopefully that's clear. Yeah. Okay, the next bit though is quarks, right? So what is the quark theory? It started off with this. So how do quarks work, right? So again, quarks work um, via the strong nuclear force. So quarks work via the strong nuclear force. Okay, we are not going to go into the very fine details here. So we'll just say here that strong nuclear force acts between quarks. Okay. The one thing about the strong nuclear force is this must be very strong. We've mentioned this before in a previous stream. Very strong. Okay, and this is very short ranged. Okay. Um. Okay, so that's how they interact. And also, the one thing that we have discovered is, Gell-Mann and Zay, when they came up with the idea of quarks, they only came up with two types of quarks. They came up with the up, so types. Okay, so up and down. Okay, now you will see that if you think about it, the up quark has a positive connotation to it. Okay, and the down quark has a negative quality to it, right? So I don't think of it as up is bad and down is good. Just say positive and negative stuff. Okay, so you can think of this as positive and down is negative. Now later on we discovered four other quarks, and you will see something here. Top, I'm gonna put that as the positive, right? So what should be the negative word for top? That's gonna be the bottom. Okay, and then the later on we discovered another two sets of quarks. We have the charmed and we have the strange. Okay, so the charmed is also positive and the strange is also negative. So you kind of see there's again, they match positive and negative, up and down, top and bottom, charm to strange. Okay, so that's the first part that you need to know, and you will need to know this as well. Of course, all the positive quarks have the same charge. It's 2/3 of the electric charge, or the charge of the electron. Okay, um, 2/3 of that. So top would also have the 2/3 of an electron, and the charges of the charm quark is also 2/3 of the electron. Okay, you can put them into you can put them together into two kinds. Okay, as hadrons. Anything made of quarks. Okay, so we're getting into finer detail from last time.